or fraudulent argument. The question is not whether we like the conclusion that emerges out of a train of reasoning, but whether the conclusion follows from the premise or starting point, and whether that premise is true. Among the tools: 1. Wherever possible, there must be independent confirmation of the facts. 2. Encourage substantive debate on the evidence by knowledgeable proponents of all points of view. 3. Arguments from authority carry little weight. Authorities have made mistakes in the past. They will do so again in the future. Perhaps a better way to say it is that in science there are no authorities. At most, there are experts. 4. Spin more than one hypothesis. If there's something to be explained, think of all the different ways in which it could be explained. Then think of tests by which you might systematically disprove each of the alternatives. What survives, the hypothesis that resists disproof in this Darwinian selection among multiple working hypotheses, has a much better chance of being the right answer than if you had simply run with the first idea that caught your fancy. 5. Try not to get overly attached to a hypothesis just because it's yours. It's only a way station in the pursuit of knowledge. Ask yourself why you like the idea. Compare it fairly with the alternatives. See if you can find reasons for rejecting it. If you don't, others will. 6. Quantify. If whatever it is you're explaining has some measure, some numerical quantity attached to it, you'll be much better able to discriminate among competing hypotheses. What is vague and qualitative is open to many explanations. Of course, there are truths to be sought in the many qualitative issues we are obliged to confront, but finding them is more challenging. 7. If there's a chain of argument, every link in the chain must work, including the premise, not just most of them. 8. Occam's razor. This convenient rule of thumb urges us, when faced with two hypotheses that explain the data equally well, to choose the simpler. 9. Always ask whether the hypothesis can be, at least in principle, falsified. Propositions that are untestable, unfalsifiable, are not worth much. Consider the grand idea that our universe and everything in it is just an elementary particle, an electron, say, in a much bigger cosmos. But if we can never acquire information from outside our universe, is not the idea incapable of disproof? You must be able to check assertions out. Inveterate skeptics must be given the chance to follow your reasoning, to duplicate your experiments, and see if they get the same result. The reliance on carefully designed and controlled experiments is key, as I tried to stress earlier. We will not learn much from mere contemplation. It is tempting to rest content with the first candidate explanation we can think of. One is much better than none. But what happens if we can invent several? How do we decide among them? We don't. We let experiment do it. Francis Bacon provided the classic reason. Argumentation cannot suffice for the discovery of new work, since the subtlety of nature is greater many times than the subtlety of argument. Control experiments are essential. If, for example, a new medicine is alleged to cure a disease 20% of the time, we must make sure that a control population, taking a dummy sugar pill which, as far as the subjects know, might be the new drug, does not also experience spontaneous remission of the disease 20% of the time. Variables must be separated. Suppose you're seasick and given both an acupressure bracelet and 50 milligrams of meclizine. You find the unpleasantness vanishes. What did it? The bracelet or the pill? You can tell only if you take the one without the other, next time you're seasick. Now imagine that you're not so dedicated to science as to be willing to be seasick. Then you won't separate the variables. You'll take both remedies again. You've achieved the desired practical result. Further knowledge, you might say, is not worth the discomfort of attaining it. Often the experiment must be done double-blind, so that those hoping for a certain finding are not in the potentially compromising position of evaluating the results. In testing a new medicine, for example, you might want the physicians who determine which patients' symptoms are relieved not to know which patients have been given the new drug. The knowledge might influence their decision, even if only unconsciously. Instead, the list of those who experienced remission of symptoms can be compared with a list of those who got the new drug, each independently ascertained.